Good morning, students. Am I audible? Am I audible? Okay. Okay. So last class we discussed about bricks, right? We discussed about different types of bricks, test on bricks. So today we'll discuss about the stone. Okay, and we'll discuss about stone. Then in the next class also we'll discuss about test on stones. Then the module one will be finished. Okay, so as we have discussed earlier that the module will one will consist of your stone and brick, and it was the module one was stone as building materials, criteria for selection, test on stones, deterioration and preservation of stonework. So, and the other part was brick. So, one more class, then your module one will be complete. Then, after that, I'll share the complete notes of module one. Okay, so let's continue with stones. Let me share my screen. Is my screen is visible? Screen is visible. Okay, okay. So let's start with stones. Okay. We'll see different types of stones.
The stones are derived from rocks which form the earth crust and have no definite shape or chemical composition, but they are mixtures of two or more minerals. The rocks from which stones are obtained may be in the following three groups. First group is geological composition. The stones are derived from rocks which form the earth crust and have no definite shape or chemical composition, but they are mixtures of two or more minerals. The rocks from which stones are obtained may be in the following three groups. First group is geological classification, and according to the geological classification, rocks are classified as igneous rocks, sedimentary rocks, and metamorphic rocks. So firstly we will discuss about igneous rocks. This image shows formation of igneous rocks, and these igneous rocks are formed due to the solidification of these molten mass laying below or above the earth's surface. Igneous rocks has a crystalline glossy or fused texture. type according to geological classification is sedimentary rocks. This image shows formation of sedimentary rocks, and these sedimentary rocks are formed due to gradual deposition of materials like sand, clay, etc., generally by setting of water as shown in this image. Sedimentary rocks are also called stratified because these rocks are formed in layers. Limestone and sandstone belong to this category of rocks. According to geological classification, third type is metamorphic rocks. This image shows the formation of metamorphic and sedimentary rocks. These metamorphic rocks are formed due to alteration of original structures under the heat and excessive pressure. Marble is an example of metamorphic rocks. Second classification is physical classification, and according to physical classification, rocks are classified as stratified rocks and unstratified rocks. So firstly, we will discuss about stratified rocks. This image shows stratified rocks. These stratified rocks are those which exhibit distinct layers which can be separated as shown in this image. An example of these stratified rocks are limestone, slate, sandstones, etc. Now we will see unstratified rocks. This image shows unstratified rocks, and these unstratified rocks are those which do not show any sign of strata and cannot be easily split into slabs. Example of these unstratified rocks are granite and marble. Third classification is chemical classification, and according to this chemical classification, rocks are classified as siliceous rocks, argillaceous rocks, and calcareous rocks. So firstly we will discuss about siliceous rocks. This image shows siliceous rocks, and these siliceous rocks are those which contain silica as the main constituent. Example of these siliceous rocks are granite, quartzite, and gneiss. According to chemical classification, second type is argillaceous rocks. This image shows argillaceous rocks, and these argillaceous rocks are those which contain clay or alumina as the main constituent. Examples of these argillaceous rocks are slate, laterite, kaolin, etc. According to chemical classification, third type is calcareous rocks. In this image we can see these are the calcareous rocks, and these calcareous rocks are those which contain lime or calcium carbonate as the main constituents. An example of these calcareous rocks are limestone and marble. Now we will discuss the important building stones, their composition, properties and uses. So first building stone is granite. Granite is an igneous rock, and it is mainly composed of quartz, feldspar and mica. In this image we can see this is the granite. Specific gravity of granite is 2.64 and compressive strength varies from 70 to 130 mm per meter square. Color of granite depends upon that of feldspar, which may be brown, grey, green and pink. This first image shows brown granite and second image shows pink granite. A fine grain granite offers high resistance to weathering, and it can be easily polished and worked. It is used for exterior facing of buildings. Second building stone is slate. Slate is an argillaceous rock. This image shows slate. This slate is mainly composed of alumina mixed with sand or carbonate of lime. Specific gravity of slate is 2.8 and compressive strength varies from 60 to 70 mm per meter square. Slate has grey or dark blue color. This first image shows grey color and second image shows dark blue slate. A good slate is hard, tough and fine grain. This slate is suitable for use in cisterns. The slate in the form of tiles is used as an excellent roof covering material. a good material for street paving. Fourth building stone is sandstone. Sandstone is sedimentary rock of siliceous variety. In this image we can see sandstone. Sandstone is mainly composed of quartz, lime and silica. Specific gravity of sandstone is 2.65 to 2.95 and its compressive strength varies from 35 to 40 mm per meter square. Sandstone's usual colors of these sandstones are white, grey, brown, pink, etc. This first image shows grey sandstone and the second image shows brown sandstone. The fine grained stones are strong and durable. This sandstone is suitable for ashlar work, moldings, cavings, etc. Fifth building stone is limestone. Limestone is a sedimentary rock of calcareous variety. In this image we can see limestone. Specific gravity of this limestone is 2.6 and it is available in brown, yellow and dark grey colors. Limestone is used in large quantities in blast furnaces. It may be used as stone masonry for walls. Next building stone is marble. Marble is a metamorphic rock of calcareous variety. In this image we can see this is the marble and specific gravity of this marble is 2.7 and it is available in many colors. Marble is very hard and takes a fine polish. These images shows various marbles in various colors. Marble is used for carving and decoration work. Seventh building stone is conker. Conker is an impure limestone as shown in this image, containing 30% of alumina and silica. The hard conker is used for foundations of buildings. Next building stone is laterite. Laterite is a sandy clay stone containing high percentage of iron oxide. Laterite has a porous and cellular structure. Specific gravity of this laterite is varies from 2 to 2.2. This image shows laterite. The laterite blocks are suitable as building stones, whereas nodular laterite proves a very good road metal. Next building stone is murum. Murum is a decomposed laterite and has deep brown or red color as shown in this image. Murum is used in surfacing fancy paths and garden oaks. Next building stone is, this is the last building stone, this is quartzite. Quartzite is a siliceous sandstone which has been subjected to metamorphic action. This image shows quartzite. Quartzite is strong and durable, and it is used as a road metal or railway ballast or in concrete. So
So, so basically, stones are derived from rocks or earth crust. Okay, and there is a major classification of rock is igneous rock, sedimentary rock, and metamorphic rock. The geological classification of rocks. Okay, so stones are derived from rocks, and rocks are classified into three categories: igneous, sedimentary, and metamorphic. Okay, so these are igneous, sedimentary, and metamorphic rocks. So they have discussed how igneous rocks are formed. They are formed due to solidification of molten mass layering below. So the lava, when it gets solidified, the igneous rock to form. And sedimentary rocks are there formed due to gradual deposition of material like sand, clay, generally by setting water. Okay, some when wind transported, when wind is to be transported from one place to another place, it used to take some soil particles and minerals. Okay, they used to get deposited in some area. So by gradual deposition for over years, it will form into a rock. Okay. The last one is they have discussed the various types of rocks under that. Then the third is chemical classification. Based on chemical classification, you have siliceous, argillous, and calcareous. Number two was physical classification. So geological classification, if they ask you for geological classification, then it will be metamorphic, igneous, and sedimentary. And based on physical, stratified rocks and unstratified rocks. Stratified rocks, there will be layers. You must have seen these kind of rocks. So these are considered as stratified rocks and these are unstratified, where you don't have any layer, just the pieces, long, big pieces. Okay. Third classification is your chemical classification, which is siliceous, argillaceous, and calcareous. Okay. Go through this video, just read one line. You just go through this simple one line definition. That will be more than enough. You should know what is what is the basic classification. Now, I am going to build their composition. So these are the granite. You must have seen granite in your kitchen mostly, and other decorating items also when we use granite is used as decorating items, but mostly they used on kitchen slabs, right? So it is also an important building stone. The second is slate. So they have, like this, they have discussed 10 building stones. Okay, all stones are used. Some stones are used in building construction in homes. Some are used as decorative piece. So go through all these marbles, right? Marbles, tiles, sorry, tiles are considered marbles. So there are different types of what you get stones. So go through this once again. Next, we'll see next next we'll see your requirements of good building stones. Okay, what are the requirements of a or you can say characteristics of a good building stones. Screen is visible. Will discuss requirement of good building stone. My screen is visible. Okay, so let's continue.
And so, what characteristics should a building stone should possess? So, let's discuss about the requirements of a good building stone. Means what characteristics should a building stone should possess for it to be used as a part of construction. So we have almost around 12 characteristics or 12 requirements that should be satisfied for a building stone, or to call it as a good building stone, the following characteristics must be satisfied. Okay, so these are the 12 characteristics I'll be explaining you one by one in detail. First one is appearance. What kind of appearance should a good building stone have? The stones, whatever you are using for face works, means for walls or whatever, whose face of the stone is open out, which is able to see by others, should have a uniform and pleasing color. Correct? Also, it should be free from cavities, it should be free from cracks, flaws, and any patches of raw material, loose material, mud material, etc. So the appearance should be very clean and neat, and the color also should be very pleasing, very attractive. Second one is strength. What a good building stone should have good amount of crushing strength, so that it can withstand the load whichever is coming from the superstructure, means from the top floors. When you're using, especially in as a building stone as in foundation, whatever the load is coming from the superstructure, it obviously to the foundation, then this stone must be strong enough to uh, take this load, and it should be able to have good crushing strength. Okay, and the main requirement is the compressive strength should not be less than 100 newton per mm square. Means the compressive strength of the stone should not be less than 100 megapascal. So you have to select such type of stone. Next, durability. So durability means in the long run how effectively your stone is working. So a good building stone should be durable enough to resist all the types of weathering activities. Whatever you have weathering agencies, whatever you have deteriorating agencies like your rain, wind, temperature, heat, whatever, to withstand everything. That is called a good durable building stone. So for a building stone should be durable enough, it should possess a fine grained, compact and crystalline structure like granite. Next we have hardness. So whatever the stones you are using in floors, pavements and aprons in bridges should be able to resist the abrasive forces, means the wearing and tearing action created from the users of that elements like floors, pavements, whoever is using that, it should be the stone should be able to resist the friction, the wear and tear action from such type of users, whoever is using that structural element. So for a good building stone to be or whenever when you say that a good building stone is possessing good hardness, means the hardness of that building material should be more than 14, and also the percentage of wear, the percentage of wearing and tearing of that building stone should be equal or less than 3%. Okay, so we can determine these values from the different tests done on the stones. Of dressing, the stone whatever you are using should be easy to cut. It should be capable of dressed into any size or any shape. Whatever size you want to cut it, you should be easily able to cut it. Whatever surface you want to make it from that stone surface, whatever way you want to dress it, whatever finish you want to give it, it should be able to be very easy operation. Yes. So whatever building stone you are using, it should be tough enough. The meaning of tough means it should be able to withstand stresses. This means the loads or stress, whatever are developed due to vibrations of the machines and also moving loads. Like for example, if you are you are using stones in bridges, so obviously on that you have train moving, on that you have vehicles moving, so it is a moving load, like that. So it should be able to resist the loads or stresses and vibrations due to moving loads. That's what you call toughness. Okay, so a building material, whatever you are using in construction in general, should be hard enough and also should be tough enough. Next is seasoning. I already told you seasoning is nothing but generally seasoning stands for removal of moisture content. Whatever stones you are getting from the quarry will possess moisture in it. They will be having moisture content in it by default. So you have to that's called as quarry sap, SAP. So you have to remove this quarry sap. This removal of quarry sap is sometimes done on the quarry at site itself or else in the place wherever you are working. But remember, seasoning means you are removing the moisture content. So whatever stones you are using, you have to take care that there is no moisture content present inside the stone. Why? Because the presence of moisture will make your stone softer, and hence early decaying is possible, early deterioration is possible. Next is resistance to fire. A good building stone, whatever you are using, should be able to resist very high temperature attacks. Means whatever the composition of the stone is there, every stone will be possessed or every stone is composed of different minerals. So whatever minerals it is having, they should all have equal coefficient of expansion. Then only they show a good resistance towards fire. Next is porosity. Porosity is obtained from water absorption test. So a good building stone, whatever you are using in the construction, should not be nature. It should be very dense and compact. It should not have holes inside. Once it is having porous nature, it will allow water to penetrate. It will give an access to water permeability. So that should be avoided. Once water starts penetrating inside your stone, it will decay your stone, it will deteriorate your stone, it will reduce the strength of your stone, and finally it will show a big effect on the structure. Hence the porosity should be very much less. So once we will perform the water absorption test and determine the porosity. For a good building stone, the percentage of water absorption should be greater than 5% but less than 10%. Okay, uh, if it is equal to 10% or more than 10%, you should avoid the building stone. So mostly we keep a limit of not more than 5%. Actually, for a very good building material stone, you should not exceed 5%, but still there will be some cases. So sometimes 5 to 10 is also acceptable. Okay, next is the building material, the building stone, whatever you are using, especially for big engineering works, for heavy engineering works, for heavy engineering structures like docks, harbors, where your ships are there, ships are loading and unloading purposes, big hydraulic structures. That stone should have very good specific gravity. Generally, specific gravity of stones or coarse aggregate, whatever we call, will vary from 2.4 to 2.8. The range is in between 2.4 to 2.8. Good building stone should have specific gravity of more than 2.7. So it should be 2.7 or 2.8. Building stone should have those grained and compact. Grains of the stone should be very closer to each other. They should be very dense in nature and they should be very compact. It should be free from cavities and pores and cracks. And last one is availability. Always see that stones, whatever you are using for your construction purpose, are easily available. You should not go for those building materials which will be or which should be imported from somewhere else, so that they are not easily available. Any decrease in the quantity, if you get a if you maybe during some planning time, if suddenly the quantity you plan some amount of stone, but what happens when you are into the actual construction, you may get short of that quantity, again you have to import it from some other place. So it's all risky job and it is not at all economical. So select a stone which is easily available and cheap. Okay, please. So
So, so these are the basic requirements of a good building stone. its crushing strength, facility of dressing, or how's the appearance, how it is durable, hard, and toughness. Okay, so these seasoning, texture, resistance to fire, water absorption, specific gravity, and availability. These are the 11 four important properties which sets the requirements of your good building stones. Okay, so any doubts from this part? Any confusion, any doubts, any questions you have? Yes, there are so many students. Any question? The next class will discuss test on stones. Okay, today we won't discuss. Today is enough. What is the good requirement of a stone? Good means good requirement uh, of a stone. It's how your stone should be, or you can say ideal stone, or you can say standard stone, which you can use. If you see these properties, then you can consider it as wait. My volume is because of now. My volume is okay. Am I audible? Okay. So yeah, basically today we discuss about what an ideal stone should be, right? If you see these properties, then if these properties are satisfying, then you can say that this stone is good for your construction material. Okay, in the first class we discussed different types of stones, and basically stones are derived from rocks, and there is a geological classification, physical classification, and chemical classification. So go through that classification once. Just the one on line will be sufficient to know about that type of rock. Sedimentary, metamorphic, igneous rocks, then stratified, unstratified, then we got calcareous, argillaceous. So just go through once again with this video, then you will understand. It is not that difficult, and the properties also. It is not that difficult. Just you have to remember. You can just like strength, toughness, hardness. What should be the specific gravity, then appearance, right? So all this will be the main properties of a good stone. So any doubts or any confusion from this part? Hmm? Any confusion or any doubt from this part? Okay, so you can write your roll numbers in the chat box. I think no doubts. Any doubts from Rick's part? Don't leave the meeting, okay? I'll call the roll call once. I'll check actually. 154, 154, 20, 26, 12, 74, 22, 40, 21, 100, 82, 71, 24, 76, 93, 73, 29, 41, 7, 81, 83, 80, 83, 33, 77, 9, 101, 43. So 72. So you all have taken as elective construction engineering materials, right? Because last class I got a roll number who is not in my means he I don't think so he took construction engineering materials, but he was in the class. And I've shared the elective list. You must all have got that. 101, 43, 72, 116. Okay. Anyone left? 30. Okay. By the your next two classes, we'll complete the module 1, and I'll share Yes, yes, we can. Please create the group if you want. Please create the group if you want. Okay, Omit, yeah, they see. Omit joined the class without knowing that he has not taken this subject. Anyways, no issues. Okay, create a group for the subject and add those, share the link. Those who have taken the subject, they will join. Then it will be easy, I guess. Okay, thank you. See you in the next class. If you have any doubts, text me in the WhatsApp. Okay, thank you.